Howdy everyone, welcome back to the next video in this course. In this video, we're going to be reading the analysis results. In some of the previous videos, you've seen some of the numbers that come out of the analysis, but what do those numbers really mean? So that's what we're going to try to cover in this video. One of the biggest metrics that we're going to cover in this video is utilization. We're also going to cover some of these sign conventions and what they actually mean. And we're actually going to reuse a model from a previous video, just that way it makes things really simple, and we're able to understand the numbers behind the variables that we change. So again, talking about utilization and what those numbers actually mean, when we don't have a load active on the beam, there's no stress on the beam, so our utilization is 0. From the 0 to 0.6 range, we're actually overbuilding. That means that you added a lot more supports than you really need, and so that translates to a really expensive build in real life. Karamba is telling you that you can get away with less, and so you can start to remove some of the material until you get to the 0.6 to about the 0.9 range. So that's leaving you with about 10 to 40% of room, and about 60 to 90% of the beam is stressed at that point. You don't want to go over that because that means that the beam is overstressed at that point. When we start going above 1, Karamba will actually show you exactly where the beam is being overstressed, so you can start to add more supports there. Again, we'll be reusing Video3's cantilever, and we're also going to optimize the utilization for the 3 different type of cases that we mentioned in the previous video as well. So these are some of the sign conventions. You can see that N is axial force, where when it's positive, it's stretching, and when it's negative, it's being compressed. Vy and Vz is the shear force. And finally, My and Mz is the bending moment. Here are some of the grasshopper components that we will be using, and you can see that they're pretty much the same as the previous videos. Finally, you should take a second to look over the common misconceptions of the utilization and some of the numbers that you're going to see. Just because the utilization is under 1, that doesn't mean that your beam is the most structurally efficient that it could be. If you've increased the weights to the most that the beam would ever experience and your utilization is still really low, that means that your beam is a lot larger than it needs to be. Remember, this translates directly to material costs in the real world. So jumping into the Rhino model and grasshopper file, you can see that the structure of this file is pretty much the same as the last video. I have modified a few things. I've added a couple labels here that just explain what each of these components do. So take a second to look over those and just make sure you understand that. These panels that show you the numbers that are coming out of these different analyzations, if you're unsure of how to connect those, just make sure to look through some of the previous videos where all you have to do is just drag the output and drag it into the input. I've added a few extra panels over here that are what we're going to be focusing on in this video specifically. To begin, let's just start by enabling our beam view. So you can see that it's red right now. And you might be wondering why that is. So if we just go over to our point load, so this is the weight that we're adding on this end, you can see that it's 0. So Karamba's throwing an error, just saying that there's no active load on that beam yet. You can see our panels are just showing zeros across the board as well. So let's go ahead and try to start increasing this now. With a load of 300, we're getting a utilization of about 0.16. So if you remember from the slides, this type of utilization is actually really low, and our support is a lot bigger than it needs to be. We can actually get away with increasing the length of this beam. So what we're going to do is we're going to highlight the beam, and then we're going to type in scale 1D. We're going to click our base point, which is the leftmost point, and then we're going to click our rightmost point, and then we're just going to increase it and see what happens. So you can see that our utilization went up and our beam deformation actually increased a lot as well. Keep in mind that this Rhino viewport is a little bit exaggerated because our utilization is still 0.28, but it's showing a pretty large deformation. You can fix this just by going back to the model view component just before the beam view component. Click on display and then just adjust the deformation. So we're just going to bring it back down a little bit here just to show what a more realistic deformation would look like for this scenario. So let's try to get our utilization in that 0.6 to 0.9 range. I'm just going to start increasing the slider, and here we go. So at this weight, when we add the load to the very end of our beam, showing a cantilever, you can see our utilization finally hits the 0.7 mark. Now let's say that your beam didn't actually need to be this long. This is showing a 6-foot beam and say that we only needed a 3-foot beam. We're just going to highlight the beam again, along with the support and load points. And we're going to type in scale 1D. Then we're going to click on the support point, click on the load point again, and then just type in 3 feet. So now we've decreased our beam length to about 3 feet, and you can see our utilization went down quite a bit. So why is that? If you think about a cantilever, the longer the beam is, the less weight that it's going to be able to support at the very end. But because our beam is shorter, our cantilever can support more weight. So now we can increase our weight by quite a bit more. So let's get back to the 0.7 range, and here you go. So now our weight is about 1500, and that's quite a lot. So this is an example of how we can use these values to adjust our design, making sure our beam is fitting the exact type of load case that it would receive in real life, while also not overbuilding. You can see in this video, we're just looking at a circular beam, and most likely you're probably not going to use those very often. So in the next video, we're going to talk a little bit more about how we can change the cross section of this beam and see how that affects our utilization and how we can start to use that in our design a little bit better.